Hello. So Barbie Bungee is a project that could be done in my Algebra 1 class after studying linear functions and giving a brief introduction to linear regression and line of best fit, which they would then be seeing linear functions being applied in the real world. So before actually showing them their task for the project, I would probably begin by showing them a video of real-life bungee jumping, where then we could have a class discussion about the relationship between the length of a bungee cord and the distance that a person drops, and how important the length of that bungee cord is for a person to have a safe but thrilling bungee drop. So after showing the video, I'd give them their task for Barbie Bungee, which is to help Barbie and Ken have a safe yet thrilling bungee jump. Safe meaning that their head doesn't hit the ground, but thrilling that they're getting as close as possible to the ground without actually hitting it. And Barbie or Ken, whichever they have for their group, is going to be jumping off the top of our math building, which is 472 centimeters high. And they're going to work in groups of 3 or 4 to collect data to determine how many rubber bands. We're using rubber bands for Barbie and Ken's bungee cords. But how many rubber bands do they need to use to help make the bungee cord for this big drop? So they're going to collect data on a smaller scale. Here's all the supplies that they're going to need. And they're going to assign, they're working in groups of 3 or 4, so they're going to assign for actually collecting the data these different roles. So bungee operator, measurer, if there's 4 people in the group, they want to use 2 measurers, and recorder. And then they're going to be inputting this data into the Google Sheets. And what I mean on a smaller scale is we're going to be inside my classroom, which is obviously not 472 centimeters. I don't have ceilings that are 472 centimeters high. But they're going to be collecting data, meaning figuring out how far Barbie drops with 1 rubber band, 2 rubber bands, 3 rubber bands, and so on, and inputting that data into a Google Sheet, which I've already supplied them with. Once they've collected all that data, they can then make a scatter plot and perform linear regression to calculate their line of best fit. I would create a screencast to actually show them how to input the data into Google Sheets, how to create a scatter plot, and how to actually perform linear regression in Google Sheets, so they could keep referring to that if needed. They could then use, once they have that equation for their line of best fit, they can do their calculations to see approximately how many rubber bands they want to use for that big drop at the top of the math building. And they're not going to get a whole number probably from their equation, but they can then decide as their group, they can have that discussion. Do they want to be more conservative? Do they maybe want to be less conservative? To really see how far or how many rubber bands they need to use to have that successful drop. So after they've done that, they're going to actually do the big drop, and I would have them video it, and they could video it from a couple angles. They all have iPads, and edit that video together in iMovie for their presentation. So in their presentation, which they can create in Google Slides or Prezi, so that I can get a link afterwards and compile all the presentations together, they need to include all of this information. So their prediction before they collected any data, their data table, scatter plot, equation for their line of best fit, correlation coefficient, which we would have talked about what that tells us about our data before the project, and then the calculations that they did using their line of best fit, and then of course their video of their actual big drop, and a summary of their results and what would they change, or was it a successful drop, but just kind of talk about the entire project and summarize. So that's it. That's Barbie Bungee.